So today we are going to understand as for the properties of a parallelogram. So what is a parallelogram? What are the different properties regarding to a parallelogram? So parallelogram is a kind of quadrilateral. Okay, we had started about quadrilateral. We had understood about quadrilaterals. So while we were discussing about quadrilaterals, we understood this thing that it is a figure which used to form by the combination of four lines. So when four lines or line segments or rays used to intersect with each other and a closed figure used to form, then that is called to be as a quadrilateral. So in a quadrilateral, when we go for more understanding in the quadrilateral, we observe that there is a specific kind of quadrilateral, which is called to be as a parallelogram. So parallelogram do have some specific conditions. Okay. So when we are talking about a parallelogram, then what it means. So basically, or very commonly, we can say that a parallelogram is a closed figure where we have four sides parallel to each other. When the four sides are parallel to each other, then that combination or that construction or that structure is called to be a parallelogram. So if we are having this kind of figure where the opposite sides are parallel to each other, they are equal to each other, the angles opposite to each other, they are equal, then they are called to be as a parallelogram. So we will discuss one by one of that thing, that how what are the basic properties regarding to a parallelogram. So first of all, some common figures which we used to see as in the form of a parallelogram, which we had studied earlier also, such as, for example, a rectangle. Okay, a very common figure which you used to study or which you had used earlier also for your calculation. So a rectangle is a parallelogram. In the same way, when you go for a square, so square is also a parallelogram which we used to have in different studies or in different kind of calculations. You all had gone for that square also. In the same way, there is a rhombus also. Okay, so you had studied about rhombus. So rhombus is also a kind of a parallelogram which we used to have. There is some specific differences or some specific conditions regarding a figure, so that we will understand that in which kind of figure, what kind of a specific condition or what kind of a specific thing which we used to see. So either we talk about a rectangle, square, or rhombus, they all are parallelograms. But when we come for the parallelogram, then we have to understand about some of the basic rules or some of the basic properties regarding to the parallelogram. So that we are going to understand, or that we are going to see over here. So the very first thing which you need to remember whenever we have been given for a parallelogram. So when we are having any kind of parallelogram, then there must be some condition which we used to observe. That is, the opposite sides will be parallel. The opposite sides will be parallel. First of all, we have to remember that one. And then with respect to that one, we come to understand that opposite sides will be equal, opposite angles will be equal. The sum of the adjacent angles will be 180-degree. So all these things we have to understand. Okay, so that is the first theorem which we have to which we are going to prove over here. So let's see for the theorem number one. Okay, so in a theorem number one, we are going to see that the opposite sides are equal. So how we can make this one? So the first one, theorem number one's first one, where we are going to see the opposite sides are equal in a parallelogram. Okay, so say as for example, you have been provided with a parallelogram. So there is a parallelogram, say as ABCD. Name I will give it later on, just a minute. Okay, so here is the figure, and it has been said that this parallelogram is there ABCD. So it has been given to you. So given ABCD is a parallelogram. Okay. So when it is a parallelogram, then we can say that therefore AB is parallel to CD and BC is parallel to AD. This has already been given to us. The thing which we have to prove, okay, so to prove what we have to prove, that AB is equals to CD, and we also have to prove this BC is equals to AD. So how we are going to prove this one? So to prove this, we have to go for one construction. We will go for one construction that will be join AC. So you can draw any of the diagonal. I am taking AC. If you want to draw, then you can draw for BD also. There is no particular thing that you have to go for that particular diagonal only. So AC. So when you draw this line AC over here, you will observe that it is dividing the parallelogram into two portions. Over here, we will have angles formed, this angle and this angle, this angle and this angle. So I will name it as, for say, as this is 1, this is 2, this is 3, and this angle is 4. So to make the opposite sides equal, so to prove this thing, what we will go for? We will go for concurrency. Okay, what we had studied in our previous classes also, that what is concurrency and how it used to be done. So on the basis of concurrency only, we are going to establish a relation over here. So if you see, by triangle ABC and triangle CDA, okay, triangle CDA. So I hope you can see these two triangles. You can recognize these two triangles. The first triangle is this one, ADC. And the second triangle is this one over here, this triangle. Okay, so for these two triangles, we will see that how they can be concurrent to each other. So we will use a property ASA. Okay, so say as we can say like this, angle 2 is equals to angle 4. So it is alternate interior angles. Okay, so alternate interior angle. Then we can say this thing AC is equals to AC, because that is common. That is common for both the triangles. And then we can say angle 1 is equals to angle 3. Again, it is alternate interior angles. Okay. So when we are having these combinations, then under these combination, we can say that by ASA, triangle ABC is concurrent to triangle CDA. CDA. So therefore, by CPCT, we know CPCT is the corresponding parts of a concurrent triangles. So we can say like this, that AB is equals to CD, and along this one, this BC is equals to AD. So I hope that you all had understood this thing. Is it clear for everyone that how the opposite sides are equal in a given parallelogram? Yes or no? Have you all understood this? How we can prove it, that the opposite sides are equal in a parallelogram? Yes, everyone? No?
Yes, sir.
Oh, okay. So I hope that everyone got for this thing. Okay, so please you all practice this proving, because this proving is very, very important. You have to go for proving in your further classes also. In this class also proving is there, but as you will move to your higher classes, provings are there. So you need to know how to go for the proving. You need to understand the steps of the proving, because proving is very common in the higher classes. So right now you are in 7. But when you go for in class 8, 9, 10 and further, then you will have proving. So provings are very, very important. So again and again, I'm repeating this thing, that you should go for the provings in a correct way. You need to understand them. If you will not understand over here, there will be a big problem for you in the next column. The next thing which we are going to prove over here, that is the opposite angles are equal. Okay, so again, in the theorem 1 only, we have to go for this thing, that the opposite angles are equal. So how we are going to prove that the opposite angles are equal? So just a minute, let's see for that one also, that how we can say that the opposite angles are equal. So this was theorem 1's part 2. We can say it is theorem number Part 2. Yes, Priyanshu, is there any problem? Yes. Okay. Now, let's move to the next one. So, let's see for that how it used to be there. 1 minute. Yes. Now, so as I said that we are going to see for theorem number 1, part 2, where we are going to discuss about the opposite sides, the opposite angles, sorry, the opposite angles are equal. So in a parallelogram, opposite angles are equal. So how we can go for this one, that opposite angles are equal. So just now we had proved that the opposite sides are equal. We have to now prove that opposite angles are equal. So as it has been given, again, it has been given that AB is parallel to CD and BC is parallel to AD. Okay, we are going to use this particular property. So when these sides are parallel, so what we can say, again, you just name the angles like this, what we had done earlier. You can name them so that it will be easy for you to express it. So as you can see, this AB is parallel to this CD, as well as this AC is parallel to AD. We are going to establish a relation. What relation we can say? We can say as AB is parallel to CD, so therefore angle 2 will be equals to angle 4, as we had done earlier. So that is alternate interior angles. So make it as equation 1. Similarly, you go for next step, as BC is parallel to AD. So therefore you can say angle 3 is equals to angle 1. Again, that is alternate interior angles. So make it as equation 2. Now, if you are adding equation 1 and 2, so just adding equation 1 and 2, what you are going to get? So if you will just rearrange, then that would be much better. Just a minute, I will just rearrange this one. This angle 1 and 3, I'm just rearranging it and I will write like this. Angle 1 is equals to angle 3, like this, then it will be much better. So over here, we can, if you will add for this one, you will get angle 1 plus angle 2 is equals to angle 3 plus angle 4. So the sum of this angle 1 and 2, when you are taking the sum of this angle 1 and 2, so what you can say, that is angle BAD, it is equals to this angle if you are saying. So you will say that this is angle BCD. So these two angles are equal. So when these two angles are equal, then you are getting this thing that the opposite angles are equal. So similarly, you can say this thing that angle ABC is equals to for the other side angle ABD. So this can be said. So like this, you can make that the opposite angles are equal in a given parallelogram. So when you are having a parallelogram, we had gone for the first condition that opposite sides are equal. Then the second proving which we had done, that is the opposite angles are equal. So I hope everyone had understood this thing. Is there any doubt till here? Do anyone is having any doubt till here? Yes or no? Yes, students? No? Okay, then can we move to the next one? The next theorem, the third theorem which we have to understand, the third condition which we need to understand, that is that in a parallelogram, each diagonals used to bisect the parallelogram. Okay, in a parallelogram, the diagonals used to bisect it. Okay, so when we are having a parallelogram, there are two diagonals. Okay, so such as, for example, this is a parallelogram. We will observe there are two diagonals. So one diagonal is this and another diagonal can be drawn from the other side like this. Okay, like this. So in this one, actually it means that the diagonals are bisecting the parallelogram into two equal halves. Okay, either we talk about AC or we talk about BD. So that will divide the parallelogram into two equal halves. So how we can go for that one? So just a minute, let me write for the part 3 over here. So we are going to see for that each diagonal used to bisect the parallelogram into two equal halves. Okay, or just bisect means only half it is there. So two equal half. So just I'm making it confirm for everyone that the bisecting is going to be in two equal halves. So bisecting the parallelograms. So how we are going to see for this one? So see, in this one again, the given thing, what is given to us, that opposite sides are parallel to each other. AB is parallel to CD, and then we have this BC is parallel to this AD. And from the previous understanding, from the previous proving which we had done in a regarding to a parallelogram, we know this, the opposite sides are also equal. We also know for this thing that AB is equals to CD and BC is equals to AD. So this also we came to know. So now we have to prove over here. So to prove that area of triangle ABD, if I talk about this diagonal, if I'm talking about this BD type diagonal, then area of triangle ABD will be equals to area of triangle, what I can say, that CDB. Okay, so if I talk about the diagonal BD, if I'm talking about the diagonal BD, you want to take it for AC, that also is possible. If you will take the diagonal AC, then we will go for the triangle ABC and ADC. So you just need to understand that for which diagonal we are talking about, and according to the diagonal, the triangle will change over there. Okay. So now let's see how to prove for this one. So if we want to make the areas equal, again, we have to just do the concurrency. We have to concurrent these two triangles. If we will be able to concurrent, then it will be very, very easy. So we can go for by triangle ABD and triangle CDB. So first go for triangle ABD and then we go for triangle CDB. So in these two triangles, what are the things which you can take over there? So you can say AB equals to CD. It is already given to us. The next thing which you can take over there, that is the next one, that AD is equals to BC. That is again given to us. And this BD is equals to BD. So that is actually common. That is actually common to us. So therefore, by SSS, triangle ABD is concurrent to triangle CDB. So these two triangles are concurrent. So when these two triangles are concurrent, so therefore we can say that area of triangle ABD is equals to the area of triangle CDB. So I hope that you all had understood this thing, that the diagonal used to bisect the figure or the bisect the parallelogram in two different halves. Okay. Is it okay for everyone? I hope everyone had understood this thing. Is it clear? These are very, very important things. These are very, very important things which you need to remember. Okay. Now we will go for the next theorem. Now we will move for the next theorem. So we are moving to the theorem number 2. So just a minute. Some students are still trying to join, but they are not able to. I think network error is there. Okay. So no problem. We have the recording. You can go through the recording also. So just a minute. We will go for the theorem number 2. These things which we had proved just now, that comes under theorem number 1 only. That the opposite sides are equal, opposite angles are equal, and the diagonals bisect the parallelogram into two equal halves. Now we are going to see for theorem number 2. Theorem number 2 we are going to see. So in this theorem, we will discuss that the diagonal of a parallelogram bisect each other. So two diagonals used to be there in a parallelogram and they used to bisect each other. Okay. So what we have to prove, so such as for example, these are the two diagonals. So say as O is a point over there, then to prove, what to prove over here? So we have to prove this AO equals to OC and BO equals to OD. So these two things we are going to prove, okay, that the opposite side, the sorry, not opposite side, the diagonals used to bisect each other. So over here, this side will be equals to this one, and this portion will be equals to this portion. So how we are going to make it, or how we are going to prove that one? So let's see and understand for this one. So just a minute. Okay, so we go for bitriangle AOB. So if you see for this portion, this triangle, okay, this portion, and another triangle would be there, and triangle COD means this triangle, this one, this triangle, these two triangles. Now, in these two triangles, if we see, then we have something equal from the previous things which we had understood, that we are having something equal. So what we can say over here, that angle OAB is equals to angle OCB. Means you can say that this angle over here, this particular angle, is going to be equals to this particular angle. So why it is so? It is alternate interior angles, which we had already proved earlier also, or which we had used earlier also. Now the next one which you can take, that is AB is equals to CD. We know for this thing that the opposite sides used to be equal in a parallelogram. So this side is equals to this side. The next thing which you can take, that is angle OBA equals to angle ODC. So you can take that for that this angle is equals to this angle. So again, we had used this one in the previous column, where we know for this thing that is alternate interior angles. So therefore, by ASA, we can say triangle AOB is concurrent to triangle COD. So these two triangles are concurrent now. So when they are concurrent, so our proving has been done. So we will say like this, by CPCT, we can say OA equals to OC, and we can say OD equals to OB. So these are the two things which we needed to prove. So it's been proved over here that the diagonals of a parallelogram used to bisect each other. So I hope that you all had understood till here. Is there any doubt regarding for these things? Is there any problem till here? No? Okay. So
No, sir.
then we can move for the next one. So another theorem which is given over there in your book, that is if a pair of opposite sides of a quadrilateral are equal and parallel, then it is a parallelogram. Okay, so here we need to prove that a given quadrilateral is a parallelogram. So how we can go for that one? So it's been provided that there is a quadrilateral. There is a quadrilateral like this, and like this. Suppose this is there. I had extended a little bit over there. So leave it, no problem. Say as this is A, B, C, D. So for the theorem number 3, if I will say, so it's been given to us that ABCD is a quadrilateral. It's been given as a quadrilateral. Okay, where it has been mentioned that the opposite sides are equal. It has been mentioned that AB is equals to CD. Opposite side is equal, and also they are parallel to each other. Only one pair is given, that they are equal and they are parallel to each other. When it is so, then we need to prove. So to prove, what we need to prove? That ABCD is a parallelogram. Okay, we need to prove this particular thing, that this given figure ABCD is a parallelogram. So how we can prove this one? So in a simple way to prove this, you have to do a construction first of all. So that is, say as you join the diagonal AC. Again, there is no particular reason that you have to go for only AC. If you want, you can go for BD also. Okay, that is completely on your choice. There is no particular foundation regarding that you have to draw the diagonal AC. So I'm taking over here AC, and with that one I will see that how we can prove it out. So see, if I go for like this again, by triangle ABC and triangle CDA. So I hope you can recognize these two triangles. Okay, ABC over here for this one, and the another one is CDA. So this side. Now, if I have to go for it, and I can write like this, that angle. What angle I will take? I will take for this one. Not angle. I will take for the side first. That would be much better. So I will say for this one that AB is equals to CD. So it has already been given to us. It's already been given to us. The next I will take angle now. So BAC is equals to angle DCA. So it will be alternate interior angle. It will be alternate interior angles. So why it is so? Because we know for this thing that that this AB and this CD is given to us parallel. They are parallel to each other. So that would be alternate interior angle. The next thing we can go for, that is AC is equals to AC. So again, it is common to us. It is common. So therefore, by SAS criteria, we can say that triangle ABC is congruent to triangle CDA. So when these two triangles are congruent to us, when these two triangles are congruent, so therefore we can go for by CPCT. By CPCT, we can say that this BC is equals to AD. First of all, that you can say as first equation. And also you can say that the angle, which angle? That is angle DAC is equals to angle BCA. So therefore, we can also say this thing that BC is parallel to AD. Okay, so make it as equation 2. So now when you will combine these two equations, so by equation 1 and 2, we can say that ABCD is a parallelogram, because it's been already given to us that AB and CD are equal and parallel, and we had proved by these two equations that this BC and AD is also equal and parallel. Hence, we can say that this whole ABCD figure is a parallelogram for us. So I hope everyone had understood this. Is it clear? Is there any doubt? Is there any doubt to anyone? If anyone is having any doubt or any problem, then you can ask. No? So I think everyone had understood this thing. Okay.
Yes,
So,
sir.
okay. So you all practice for these. You practice for this. So in tomorrow's class, tomorrow again we will have class. So in tomorrow's class, we will discuss about the properties of some of the basic kinds of a parallelogram. Okay, so we had already studied that property also, but again we will discuss about the properties of a parallelogram, so that it will be much easy for you all to understand that what are the basic properties of a rectangle or a square or a rhombus or in a trapezium or in a kite, so that you can be able to do the exercise in a proper way. Okay, so once you all go for these proving, I'm repeating this thing that provings are very, very important. If you are not going through the provings, then there will be problem for you all in the future classes. Okay, so please go through the provings and do it in a proper way. Go through each and every step in a correct manner and then do it. Okay, so please do for these things. And what we had revised in the previous column, that also you just go through so that it will be easy for you to do this exercise. Okay, so we will have the class till here only for today. And then again, tomorrow we will have class. So in that one, we will discuss much on this. Okay. So for that time, I'm ending up the class over here. Thank you for now, everyone. Bye.